Hello and welcome back. In today's video, we are continuing COMSOL user interface part 3. So in this video, we are dealing with the home tab. Currently, we are studying the ribbon of the COMSOL user interface, and we started with the home tab, and I explained all the tools, all the features in the file tab, and now there is a second tab called the home tab, and the features under the home tab will be explained in this video. So let's start. Now we'll move to the COMSOL Multiphysics software. This is the user interface. Now if we see, this portion here is the ribbon portion, and first tab is the file, and all the options under the file we explained already. Now we have home tab. Now this is the tab when we open the console. This tab is by default selected, and these are the options in the ribbon under this home tab. Now first of all, we can notice that if we see the tabs of the ribbon, we have, after the home tab, we have definition, there is geometry, then material, then physics, and so on. And same names we can see under the home tab. If we leave the first two sections, we have here definition is also seen here. Then we have geometry, then we have geometry here. Then we have material, then we have material. Then we have physics, then we have physics here. We have mesh is here. Then study is here. Then results is here. And some additional features like these last two and the first two sections. So what does it mean? If the tabs has these names, then why are these names under the home tab as well? This is because the home tab has been designed to bring the basic features from each advanced tabs under the home tab, so that we are in a position to make a basic model directly from the home tab options, and we do not need to go into these advanced tabs. For example, if we go to the, say we go to the materials tab here, materials section here, which is under the home tab. So material has one option, it has add material, because mostly what we need is when we make a model, we have to add the material. We click here, it opens the library, and we search which material we want to add. We write it in the library search bar, we write the name of the material, and we click add, and it gets added. This is what we need for basic models and for basic tutorials. That's why this has been placed here. Now if we go to the actual materials tab, we see more other options available under the materials tab, and the first one is add material. Then we can have, when we move to the advanced level or intermediate level of learning the COMSOL multiphysics, then we will learn about these other options. For example, the second option here is add blank material, which means it will add a material that will not be having any properties added with it, because it is blank. So we are defining a new material, and we are free to we are free to input the details of the material whatever we want. Density, I want to put a hypothetical material with density this, okay, go for it. We can put the density value, specific heat value, thermal conductivity value, or any other thermophysical properties we can put. We can save it, and then we can use it, and we can assign it to our geometry. There are many other options here, but the first option that is more frequently used for basic models, which is the add material, it has been put under the home tab in the materials section as well for the quick access. So this is what basically the home tab is for. All the basic features from these main tabs have been put here as well for quick access, but there are few options that are in addition to that are here. First of all is workspace has application builder and model manager. I have told many times that these have something to do with when we are building a COMSOL customized application. When we are building apps, then when we create apps, this is where these options are useful. And last, layout section under the home tab is also new here, which is Windows and the reset desktop. We will see about these. this model is also something that we know about. When we open COMSOL, we select a model wizard, and the first option it tells us is which space dimension we want to work on. Something like this we have seen. So this model component has add component, whether we are working on a 3D model, 2D model, 1D model, or 0D model. This is the section for that. So basically it's all these options are just for quick access under the home tab, and we can access all these options from the respective tabs over here. So let's move on. So we will leave the first section here, which is workspace, because it is something that is for advanced users. We will leave it, and we will cover this in advanced tutorials, and we will leave this or intermediate tutorials. Now moving to the model, first of all, what we have here is we have add component, and we have select a component which is not clickable here. And because when we add a component, it gets added here. Suppose if we click add component, suppose we are working on heat transfer through a metal rod, and rod is a cylindrical shape which is 3D. We click 3D. So we can see here component 1 here gets added. We can even name this component. We can name this, say, aluminium rod. So aluminium rod, we renamed this, and there we have component 1 which we can work on, which is aluminium rod, and these are the options that comes with it by default. Okay, now this option is now clickable here. It says aluminum rod. So this option says us how many components we have added here. So suppose if uh, we have added one component called aluminum rod. Now if suppose we are working on a multi-physics problem, and we can add another component as well, which can be of different spatial dimensions. Say we select a 2D plate. Suppose we are simultaneously we are suppose working on a problem that involves two geometries. One is cylinder heat transfer through a cylindrical rod, and another is heat transfer through, suppose, aluminum rod, and another is heat transfer through aluminum plate, which is a two dimension. So I add two dimension here, so we call it aluminum plate. So second component I also added aluminum plate. So this is the beauty, this is the capability of COMSOL multiphysics. We can add many components, we can assign material geometry and physics to each component, and it will couple them together, and we can solve uh, all of them like in a sequence to get the final results. It couples all these physics together so easily and so simply. What we have to do is, if we suppose under we are in component 1, there we will get some result. Say it is a heat transfer, we will get the temperature along the aluminum rod. Then we use the temperature distribution inside the aluminum plate, say, and it will start solving for aluminum plate for something, and give the final result. So it will take the input from first component and solve it. For example, let me give you a simpler example. Suppose under component 1 we are solving, suppose, heat transfer through a fluid that is flowing through a pipe, and this first component will solve for the temperature distribution. Suppose temperature heat transfer that will occur from hot fluid inside the pipe to the pipe material, and the temperature of the pipe material will increase. How much it will, suppose, take the maximum temperature that that pipe material can reach to. Now this maximum temperature will be used by, suppose we use another component, and in that we are solving the structural, we are assigning a structural analysis physics, structural physics. So in under the second component, we will use that maximum temperature from the first component, or it will itself use the maximum temperature from the first component and use it in the second component to calculate the stresses, thermal stresses that can be induced inside the material because of this high temperature, and give us the final result, the sections where maximum thermal stress can occur, and pipe can break, or pipe can fail. So this is how it easily couples different physics together. So if we click the aluminum rod, now this option here, it shows us aluminum rod, aluminum plate. That means we have added two components here for our two different geometries. So this is the model section. Then moving to the definition section. We have function, and there's something that's not clickable here is parameter case, which this is like related to the advanced tutorials. It has something to do with the sensitivity analysis when we add parametric sweeps and all that. So we'll leave this option. So we have main three options that is good for good to be learned for beginners. At first is the parameter, the second is a variable, and third is the function. So first of all, parameters and variables, these are same as constants and variables in mathematics. In mathematical equations, when we suppose we have an equation, and this equation consists of two types of symbols that we see. One types are called like constants, and other types are called variables. Now in COMSOL terminology, the constants are named here parameters, which we also call them parameters. So if we want to add a constant, we click parameter and add parameter here. Suppose, for example, we are solving a simple basic, say we are solving a gravitational problem. Suppose gravitational force between two bodies. So we know in this solving this equation needs knowing the needs the use of universal gravitational constant capital G, which is 6.67 times 10 to the power minus 11 Newton meter square per kilogram square. So this is the constant. It doesn't matter how many components we added, and if all components deal with solving for gravitational force, all of the components need that G. So what we do is we add a parameter. We can see parameter 1 is already added. So it can be seen under the global definitions parameter 1 here. So what we'll do is we go to the name, we call it capital G, and expression is its value 6.67. and we'll give unit Newton meter square per kg square. So here we have 6.67 e to the power minus 11, and we have here some syntax error. Newton meter square, Newton into, we write into Newton meter square per kilogram square. There we go. So if we see any syntax error here, any underlining here, that means something we have not done right. So if we see the proper value coming here and with proper units, it means that we have put the numbers and units correctly. So we can see it is Newton meter square per kg square here, but here it shows meter cube per kilogram second square, because it has converted. It has suppose it has used kilogram meter per second square for Newton, and it has used that and solved and cancelled the some same units, and it has reached to meter cube per kilogram second square. So this is what we mean adding a parameter, defining a constant. So in the global definitions we have defined G. Now we can use this symbol G inside component 1, we can use it inside component 2, and it will recognize it, and it will bring the value from this global definitions and use this value under first component. We can use under second component. This is what adding parameter globally means. When we add something globally, it means it can be recognized by all the components. When we add something locally, adding locally means we can see under global definitions we have under the main root we have definitions, global definitions, and but under each component we have separate definition. Under this component we have separate definition. So there is definition in the global option, and there is definition under each component. So when we define some parameter, some variable under the global, it will be recognized by all the components. When we define it under this component, it will be recognized by this component only and not by this component. And if we define parameter under this component, it will be recognized by this component and not all other components, because this is local to this component. We have defined it local to this component, and if we define it here, it will be recognized by all the components. This is what global and local mean. So we have added a parameter. Now after that, we may need to add variables. So if we click variables, now we have options: global variable we want to add, or we want to add local variable. If we add global variable, the variable will get added under this. If we click local variable, it will get added under this or this, depending upon where we have selected, which option we have selected. Suppose if I have selected, suppose first of all I will go and click global variable. I click global variable, see it got added under global option. Now this variable which we define here will be recognized by all the components. We will put a name here, and then if we use that name under component 1, it will recognize it. Under component 2, it will recognize it. Now if we add the local variable, right now the component 2 is selected. If we add local, it gets added under the this local variable. If we want to add any variable here that we want this component to recognize and not any other component, we want to use it in this component, so we will be defining it under this component. So we selected this, we click variable, then add local, and it will get added under this component, and whatever name we put for this variable will be recognized by this component only. If we use that name inside this component, the console will tell us the variable is not recognized. So variable can be anything. So it is a Reynolds number, so we'll name it RE, then we'll write its expression. Say Reynolds number depends on, we'll say rho or HO rho, then multiply by velocity, say v, then multiply by characteristic length L, divided by mu, say mu. So we have defined a variable Reynolds number here. But if I click outside, it will show underline. Why? Because it doesn't recognize rho, v. These are the names, names. We have not defined anywhere. It's like programming. Rho, v, L, mu. So these rho, v, L, mu we have to define first. So rho will be constant, v will be some constant fluid velocity, L will be some constant, mu will be some constant. That means these are constants. Constant means variables. Variables means we have to add parameter in the parameter section, which always gets added under the global, because they are constants. So there is no meaning of adding them locally. So it has only meaning adding globally, because constants are constants. They will be same under all components. So we will go to the parameters, and here we will add rho or HO rho and give its value. Says we will give 300 is the density. We'll start square bracket as already said, then kilogram per meter for power this, then cube, and close the square bracket. Now we have defined the 300 kilogram per meter cube. Then we use another term is velocity v. Suppose we give its value, say velocity is 5 meter per second, 5 meters per second. So we have 5 meter per second here. Then we use another parameter in the Reynolds number is L, characteristic length. Say it is 0.05 meters. So we have 0.05 meters. Then we use mu value. Say mu value is something like 0.3 Pascal second, Pascal into second, close. See, we have had Pascal second. Now when we go back to the variable that we defined under this RE, now we do not see any syntax error or any math error. There is no underlining, which means it now knows rho, it now knows VL mu. Now I defined under global definitions these parameters. Now these got recognized by this component. We can see that it recognized them. That is what I meant. Whatever we define under global definitions will be recognized by all the components. Even this will recognize it. Even this will recognize it. Suppose if we'll go here and use, say, something else we want to define, we want to define something yu, whatever, hypothetical property. So but it also depends on density, say RHO, and it is equal to divided by mu. See, rho mu. It also gave the units from its side. Now it did not tell us I do not recognize, because I'm in the second component. It did not tell us I do not recognize rho or mu, because these are recognized by all the components as they are defined under the global definitions. Now moving forward, then we have functions. Now we have functions. Now what does function mean? It is same as mathematical function. If we are solving a problem where something is changing with the time, or something is changing with spatial coordinate. Say something is changing with time. If something is changing with time, we want to know how it is changing with time, what type of mathematical function it is obeying while it is changing, whether it is changing linearly, quadratically, cubically, biquadratically, exponentially, logarithmically, sinusoidally. Doesn't matter how it is. We want to apply that condition according to that proper mathematical function. So for that, what we'll do is we'll go to function, and we have all these types of functions, spatial and these primitive functions as well available. And we see these functions are categorized under global. They are categorized into global types and local types, and they have the same meaning. If you want a function under the global definition, we click it from the global category. If we want it to add under component or component 2, we will select the same functions are here and here, so we'll click that function inside the local category, and it will get added here. Suppose I chose the second component, and I want to add a function, yes, analytical function. So I added analytical function, and it got added under the component 2. But if I wanted to add a globally, so suppose if I add analytical function under the global category, it will get added under the global. Now it will be recognized by this, add this. But if I want it to be recognized by the second component only, then I will click here and add it locally. Now an example where we can use it. Suppose suppose we come here, and suppose I want to study heat transfer through a rod, and this rod I have put in the air outside. Now if we see, I want to study the temperature distribution in the rod for the 24 hours of a day. So now if we see, the external temperature outside will vary. It will be, suppose something at, it will be, suppose initially, suppose in the midnight at 12 a.m. it will be something minimum value, say 2 degrees Celsius. Then moving to, suppose 2 p.m. it will be something like peak, it will be something like 25 degrees Celsius, say. Then it will go back, say to 9 p.m. it will reduce back, suppose it goes back to 5 degrees Celsius. Then 12 a.m. back, and it will move to 2 degrees Celsius. So it's a variable temperature. So if we see, it will be something like sinusoidally, it will be some value, then increasing in the noon, decreasing in the evening, then more decreasing in the late night, then decreasing in the late night, then increasing back. So it is that time is varying, sorry, temperature is varying with time here, and we want to apply this external temperature as a boundary condition to this rod. Say we will insulate this end, we will insulate this end, and one end is kept at, say, 20 degrees Celsius, and another is given this external temperature T of T. How we know? Giving this temperature on one side, what we'll do is we add temperature and give it value 20, and another side we do not have the constant temperature value. How will we add this variable temperature? This is the type of examples where the use of this function comes in. So if we come here, and if we suppose make a rod, suppose we go here, we have to add a geometry. So we'll see in the geometry section we can add this geometry. But another way is right click, sorry, first of all we have this geometry here. We will right click on this geometry. Here we have options for the geometry, whether we want to add block, cone, cylinder. We'll cover this in detail in the future video. So I added cylinder, so we can give radius of the cylinder, height of the cylinder. Say radius is 1 meter and height is, say, 4 meters, and I click this build all, and we have a cylinder here. This is how simple is to make a geometrical model here. So here So what I want to do is, so I add material to it. So I go to materials option here, I click cursor here, I right click and I see add material from library, or I go here in the material section and select add material. So I added material and I can write aluminium. I wrote aluminium. It will find aluminium for us of different grades of aluminium. Say we are using this, I click this, then add to component. Here we also add to global component, so it will be recognized by all. Or if I want to add it under this component, I have this material selected. I will click add to component and it will get added under this component. So, and this blue color means the material has been assigned, and these are the properties of the material. This we will talk about in the future videos. What I'm trying to teach here is how to add this functional form of temperature boundary condition. So here we have temperature that we have to apply is the 20 degrees Celsius. So we go to study, which we have not added yet, because we are studying heat transfer. We have not added yet. That physics is here. Suppose add physics, heat transfer in solid, add to component, aluminum rod. So study got added. So when, because these boundary conditions we can add in the study. So we right click on this study. So heat transfer we can see under this here. Let us compress this component 2, so we can see only the options under the component 1. Let us compress the geometry. We have assigned the material. And under the material it says cross, it shows this cross, which means some properties are not as defined under this. So we have to see what thermal conductivity is. Say it is thermal conductivity is 23, density is something like this, specific heat is something like this. So all the main property, if all the properties that this physics needs to solve this problem are not present here, it will show us cross. Not all means the properties that this physics needs. If it's we are solving a heat transfer problem, the property that we are interested in are density, thermal conductivity, specific heat. So these three were not defined here. These three were not defined here. That is why it showed cross. Now I defined these three. Now it is not showing cross. If I remove, even if I remove this property here as well as this property here, it will not show us cross, because this physics only needs first three properties. That's enough. So this is the material. Now what we want to do is apply the boundary condition here. We go to this physics, we right click, we see temperature here. Now we click the phase where we want to apply this temperature conditions. Here it is blue now, and here we write the 20 degrees Celsius, which is 293.15 Kelvin, already written there by default. So we have assigned a boundary condition. Now on the other side, we have to apply the boundary condition that is not constant number, that is some variable, which is that is some functional form, where which function we can add here and apply this. How? For that we have to go to this physics with this component, then apply the function. Suppose we are applying some analytical function or any type of function. Suppose we have tabulated data. Now what we want to apply on this side is external temperature. Now external temperature, usually we contact the meteorological department, we get the hourly temperature data from the outside. So what we'll be having is 24-hour time and the corresponding temperature values. So we have some kind of table with us. So what we'll do is, if we want to add some property that varies, and that variation is available to us in the form of a table. So further we define this interpolation function. So it gives us this local table. Here we can write temperature. Say we call this 0 initially the temperature was minus 2 degrees Celsius or whatever, say 2 degrees Celsius. So t is time is hours. So what we'll do is, for time we will choose h. For hour the unit is degrees Celsius. So DEGC. So this is degrees Celsius temperature, small d. We will label it as, say, external temperature T, and function name will get a name will get TEXT. So this is the name that we have to use in the when we apply this boundary condition. So we define the units as well. Then we go to our temperature boundary condition. We see uh, we will write T external. We have to use here T ext of T parenthesis small t. This means T external depends on T. Now it does not show us any warning, any error, because it has taken this T external of T which we have defined here. So I have applied the constant temperature boundary condition on this side, which is 20 degrees Celsius, and variable temperature boundary condition on this side, which I have defined the from the function here. So this is what it means adding a function. And in the same way, we whatever function we want to add, mathematical function we want to add, we can add from here. Now then we go to our geometry section where we build our geometry. Now we can use these options here, or we can go to geometry. We can see under the component we have geometry. We can right click and we get all these options here. We can add block, cylinder, sphere, or whatever. Now here we have four options. One is import, live link, part libraries, and build all. Build is when we suppose right click here, I want to add a sphere. I give the radius of the sphere, then I build, it builds us here. The sphere is right now here. Now suppose if I can change the coordinate, say I can change the coordinate from this to 1 and build again, so I can change wherever it appears. So build all means when we are creating that geometry, we are telling the COMSOL just create the geometry that we have defined here. Now, import means something we can import from the, suppose we have a model that is saved in our file explorer, in our memory of the PC. It is saved here, and if we want to import that geometry and we want to simulate that geometry, we have this import option over here. When we click that, we name the file and we browse from here, and it will take us to the file explorer. Now then there is part library. Part, if we click the part library, it takes us to this library where we can use the COMSOL's inbuilt parts. If we suppose if we are working on a heat transfer, heat loss, or heat dissipation through an electronic system, so electronic cooling is the problem. We go to the heat transfer, then we have heat sinks. We double click here, say first of all we will delete this import option because we have not defined this import option, so it is showing us error. We have not defined the import options here. So right now we are in the part library, so I double click this and I say double click it. These are the features, the characteristics that we are defined for, that are already defined for this heat sink that we added from the part library. We click build all. Here we have the heat sink. This means part libraries means using the COMSOL's inbuilt library parts. If the problem we are working in, the geometry is already available in the library, we can import and we can use that. Like this heat sink, it is already made, we can use that. That is what part library is for. Then there is geometry. One option, another option in the geometry that we can use is live link. What this very important feature is here. Some people are specialized in different CAD software. Suppose I am specialized in SolidWorks and I know SolidWorks very well. I can build a complex geometry inside a SolidWorks better than I can create in this COMSOL, because COMSOL does not have that sophisticated CAD features. So what I can do is I can open the SolidWorks software. I can make my model over there. When I'm finished with the model, I save it. I keep the SolidWorks interface open with the model, with the made model there. Then I come to the COMSOL Multiphysics and I find live link for SolidWorks. I click the SolidWorks live link for SolidWorks. When I left click it, it will connect me to the SolidWorks. So it will see if SolidWorks is open, and if it is open with a model. If it is open with a model, it will, if I click here, and it will bring that model directly here. That's what it means. Now if we are using a CAD software, AutoCAD. So if we are using AutoCAD, I will open the AutoCAD. I will make the model. I will keep it open. I will come here, click the live link for AutoCAD. Now it will connect me to the AutoCAD using the live link for AutoCAD. So it will connect me to the AutoCAD and bring that model here directly. And for all other, we have options for Inventor, for Creo, for Revit, for SolidWorks, for Solid Edge by Siemens, and all that. So this is the geometry. Then we add material. I showed, we click here, we find the material, and we add to the component, and material gets added. So these are the options actually that have been put in order. If you see, check one of my videos, I will put the this link here. You can see that I have shown how we solve a problem in COMSOL. Steps to solve a problem in COMSOL. We first define some properties, then we create geometry, then we assign material, then we add physics. This is the order in which we go. Then we mesh it, then we add the study, time dependent or not, then we run in the study, we run the model, and we get our results. So this is the order in which we go. So the same order is given here. Then after adding the material, then we add the physics that we have already added. Add physics means adding new physics. It will open this library. We can find out physics, which type of physics, whether fluid flow, heat transfer, electrochemistry, we can add from here. We can even add a mathematical equation, math physics here, sorry, a mathematical model here, whether partial differential equation we want to add, or ordinary differential equation, or whatever. So whatever physics is added will be shown in this. I have added heat transfer solids, it is shown here. Then we have mesh. Then when the model is ready, when the boundary conditions are applied, then we have to mesh it, discretize our geometry to solve it, which I have explained in another video, meshing and discretization. I will put that link over here. You can see, find that link in the description box as well. What is meshing and why is it needed? Then we will mesh it. Suppose if we click mesh and then build, see, this is the meshing, converting the entire geometry into smaller segments, because it solves them each, it starts solving each segment separately to give us the value in. This is what numerical analysis means, and you can check my video, discretization and meshing in detail here. Then after this we click add study. Then add study means whether boundary conditions I applied depend on time or not. If they do not depend on time, suppose if we go back to the rod case, if the temperature is here 20 and here is 100, that means temperature boundary conditions are constant, they are not varying with time. So we choose a constant temperature boundary, we choose the study as stationary. Suppose if we go back, one side is 20, another side is temperature, that's varying with time, so we select the time dependent here. This, suppose we choose this time dependent, then we click add study. Now it study adds the study and shows it is time dependent. This is what adding study means. So it shows us here study 1 has been added, and that study 1 we can see here, that study 1 time dependent study we have selected. Okay, then under this study, time dependent study, this is the time we put. We want to start from 0, means the 0 time. We want to go, this third option is up to which time we want to go. Suppose for 24 hours, so we'll write 24, but since it is unit is second, so we have to convert this 24 hour into seconds, which is 86400 seconds. And suppose time step we want to take, which again the discretization concept, you can check the video, this middle. So in the range there are three values: first, middle, and last. First is the starting time, which is 0, and is the ending time, which is 24 hours, and middle is the interval is in which we want to break this 24-hour time interval, 24-hour time domain. Suppose the interval is we want to state it for 1 hour, so we'll write here. So it will divide the whole 24 hours into 1 hour and solve for 1 hour. Then we click compute, and it will start solving this problem for us and give us the results in this results section. Then we can add plots, graphs, and all that. So this is how problem is solved in COMSOL, and these features that are added under the home tab are the features we often require to solve a basic COMSOL problems, or even intermediate problems. For advanced problems, we have to use these tabs. We have to go into these tabs and use these advanced features. Now then there is this last section, which is the layout section. Here what we can do is, this is Windows. This shows, this is an option they have put here where we can add anything. We can add physics. Of course we can add physics from here. We can go to physics and add physics from here. But they have put all these addings under this: add physics, add multiphysics, add this, add templates, add material, browse material. All these options are, again, we want add a table, everything we can add from here as well. So no further explanation is needed. Then we have this reset desktop. What reset desktop means is, sometimes we want to, we have a complex model and we want to increase the graphics window space. So we do like this, then we zoom it further, something like this. We bring it to home here, so we increase it. Then we suppose for we can customize this user interface. We can bring it here, we can increase this, we can decrease it. Then finally we want to go back to the default setting. What will go, reset the desktop. I reset it, and it brings everything back to its normal position that it was by default. So these are the options under the home tab, that we very quickly covered here. And to get the in-depth sense of these features, these tools, you have to keep watching the future videos where we will use all these options one by one, and you get properly familiar with all the features in future. Thank you.